Hello students, in this video I will be going through some examples with you guys on how to operate functions. So when I say operate on, I mean to evaluate functions as well as to, perform the 4 basic operations for. Alright, so let's take a look. So the first question here, well actually not the first question, but what's presented to you right now is 3 different functions. Have f of x, g of x, and h of x. Please do not confuse the x that's inside of the parentheses of each one of these functions as a multiplication operation. It is not. So what this is saying is, okay, x is the input and f will be the output. X will be the input and g will be the output. X will be the input and h will be the output. So for instance, if I wanted to evaluate f of 1, the input is 1, the output is whatever that f evaluates to. So this is going to be 2 times 1 minus 3, and that will give me -1. I want to evaluate g of 2. So the input is 2, and the output is what g evaluates to. So that will be 1/2 times 2 squared plus 2, which is 4. We repeat this again. The input is 3, and the output is whatever h evaluates to, and in this case, h evaluates to -6. So there you have it, okay? That's how we evaluate functions. Wherever we see x, we are going to replace it with whatever the number or expression or whatever, okay, with what's in here. What was x, okay? Let's take a look at another type of question. So next, we're going to be operating on this function here where it says f plus g of x, and notice right here I have written on the side just to remind us what f, g, and h is, because we will be using this all throughout the remainder of this exercise. So right now I have f plus g of x. Now the notation here, what this is saying, oh well, take both functions f and g and perform this operation. Wherever you see, so what you're going to do is we're going to take f and g the way we see it. This is 2x plus 2x minus 3, and we're going to add that with 1/2 x squared plus x. And what we do with this is we got to combine like terms. So this is 1/2 x squared. 2x and x makes 3x. And then the -3 does not combine with anything. So that is the result of adding f and g together. Let's move on to the next one. I want to now subtract f and h. So how are we going to do that? Well, that's exactly what it says. So this is, again, interpreted as f of x minus h of x. So this is the same thing as 2x minus 3 minus 2x over x minus 4. So what we want to do with this, okay, is we are going to subtract these two things, even though it's expressed kind of like a fraction. Not kind of like a fraction. It is a fraction, okay? We are going to subtract these two by creating common denominators. So 2x minus 3 right now, technically, that is a fraction because it's over 1. I need to create common denominators in order to add this through, or subtract this through. So what I'm going to do is I am going to multiply 2x minus 3 over 1 by x minus 4 over x minus 4. So I'll have x minus 4 times 2x minus 3 over x minus 4, subtracted by 2x over x minus 4. And we're not quite done yet. We're going to perform a little bit of simplification, and then we're going to and then we'll be done. Okay, so we're going to FOIL out the numerator, so that becomes 2x squared. And I want to do this a little quickly. Okay, so it's 2x squared, and then I want to have minus 11x plus 12 all over x minus 4. minus 2x over x minus 4. And since I have two fractions with the same denominator, I can place this all on top of the same denominator. So this is going to be, I can then subtract and combine like terms. So I have 2x squared. The negative 11x minus 2x becomes minus 13x and plus 12. There you have it. All right, moving on. Next, I will be multiplying f of x and g of x together. So what will this be? That's exactly what it is, what it's saying to do. So we are going to be taking 2x minus 3 and multiplying it by 1/2 x squared plus x. So we will need to FOIL. So this one here we cannot do as quickly just because they're not of the same degree. So 2x times 1/2 x squared, that's going to be x cubed. 2x times x, that's plus 2x squared, minus 3/2 x squared, minus 3x. Combine like terms, I get x cubed. The positive 2 and negative 3/2 gives me positive 1/2 x squared minus 3x. That's the product. All right, moving on. We're going to be evaluating the quotient now, f divided by h. We're going to do exactly what this is saying. So this is saying 2x minus 3 divided by 2x over x minus 4. Now say, well actually, let's get through this first. We now have this complex looking fraction, right? The denominator is a fraction, but that's okay, no biggie, right? Because we know how to divide fractions. 2x minus 3 technically is over 1, right? So when we divide fractions, okay, we got to flip the we got to flip that second fraction, or we got to flip the fraction that's underneath, and then it becomes a product. So this is x minus 4 over 2x. And again, we're going to perform a little bit of simplification. This becomes 2x squared minus 11x plus 12, all divided by 2x. And there's really nothing else that we can do with this because there's no common factor between the numerator and denominator, so we're just going to leave it like that. Now suppose if the question was, let's say f or g divided by, or f divided by g, right? In this case, what we do is we do 2x minus 3 all over 1/2 x squared plus x. Now in this case right here, I mean, the denominator is not it is factorable, but there's no common factor. If we recognize that there's a common factor between the numerator and denominator, we would continue reducing. Otherwise, if there's no common factor to reduce, we would leave our answer just like that, actually. Well, I would maybe play around with this 1/2 there just because it looks a little irritating. So maybe what I would do is I would create common denominators again. So I have x squared plus 2x divided by 2. And then this becomes 4x minus 6 all over x squared plus 2x. Maybe that's something that I would do, but honestly, leaving the fraction in this form is sufficient, but recognize, you know, we can manipulate the final answer to look like many different forms, okay? You just need to be comfortable in your ability to manipulate and rewrite these different expressions. That's the whole point of this. Okay, next, this is something new, okay? We have g of f of x. Now what this is saying, okay, this notation here, this is a composition of function, okay? And what this is saying is, if you recall from geometry, actually, right, when we perform a composition of transformation, let's say, it's written in very similar notation. This is saying we're going to take f and we're going to throw it inside g. Okay, so we're going to evaluate g by first taking f and throwing it inside of g. So how does that work? Well, f is this thing over here. Wherever I see x, and I see x in a lot of places in g, okay, I will replace it with, wherever I see x, I will replace it with f. So how does that work? Well, it looks like this. G, okay, is 1/2 x squared, right? But instead of writing x, I want to put in 2x minus 3. And then plus, instead of writing x, I will put in 2x minus 3. Why? Because that's what f is. F is now inside of g. And I will try to reduce this, okay? So what I have here is 1/2. This is a perfect square, so it's 4x squared minus 12x plus 9. Again, if you remember your structure, right, then foiling this takes less than a fraction of a second. And I want to distribute the 1/2 through. So I get 2x squared minus 6x plus 9/2 plus 2x minus 3. And finally, combine all like terms. Combine all the x squares together, right, which there isn't any aside from just that first one. The negative 6x and positive 2x is minus 4x. 9/2 minus 3, well, that becomes 3/2 plus 3/2. So that's my final answer right there. 2x squared minus 4x plus 3/2. And moving on, now we're reversing it. Well, I have f of g, right? So wherever I see x inside of f, I'm going to replace that with g. So this is the same thing as f of g of x. So again, f is 2 times x, right? But I'm not going to write x. I'm going to put in g, and that is 1/2 x squared plus x. And then minus 3. So what is that? That's going to be, distribute the 2, I get x squared plus 2x minus 3. This question is a lot simpler than the last one, right? Just because f is a simpler equation, that's why. All right, let's take a look at another one. F of h. F of h. Okay, so what this is saying is h is going to go inside of f. So again, this is going to be 2 times x, right? And what was x? Oh yeah, it's 2x over x minus 4. And then minus 3. Distribute the 2, right? I'm going to have 4x, or rather multiply the 2. 4x over x minus 4 minus 3. I'm going to combine things together. So I get 4x over x minus 4 minus 3 times x minus 4 over x minus 4. And what will be the result of this? Well, I'll have 4x over x minus 4 subtracted by 3x minus 12 all over x minus 4. Since I have two fractions with the same denominator, I may combine them together. So I get 4x minus 3x minus 12. And notice I place 3x minus 12 in a set of parentheses because I am subtracting all of the numerator all over x minus 4. Distribute the negative. I get 4x minus 3x plus 12 all over x minus 4. And finally, this just becomes x plus 12 all over x minus 4. All right, moving on. Next, I have h of f. This is the last one, h of f. Okay, so this is saying place f inside of h. So wherever I see x inside of h, I'm going to replace that with 2x minus 3. So it's 2 times 2x minus 3 all over 2x minus 3 minus 4. Distribute the 2, I get 4x minus 6 all over 2x minus 7. And there's no common factor between a numerator and denominator, so therefore this is where I'm going to leave it.